Is that better? Awesome. My name is Sam George. I am the director for Azure IoT. I'm going to be talking today about Microsoft's sort of end-to-end vision around IoT, both on the Azure side. I'll also be covering the Windows side as well today. By a show of hands, how many folks in the audience already have an IoT deployment of some sort that they manage? And so just a few, maybe 5, 10%. Over the course of the next year, how many folks are planning an IoT deployment? And then everyone else, I assume, is just generally curious about IoT and what Microsoft's doing. How many folks consider themselves a maker? Cool. I actually would as well. Awesome. Well, let's get started. I'm going to click my way. Okay, great. So today we're going to be talking about, at the beginning, we're going to talk about the IoT opportunity all up and a whole set of considerations around it. I'm going to cover in detail Azure IoT, what we have planned, what we have already available that customers are using. I've got a few use cases that customers are already being successful with our Azure IoT services. Then I'm going to be talking about Windows 10 IoT. So IoT is a really interesting inflection point. We don't kid ourselves and think that IoT is something new. It's been around for a long time. It's been called a lot of different things, of course. It's been around for 20 years. There's a bunch of things that are creating a different IoT today, or a different phenomenon that we're collectively calling IoT. And it's really an inflection point around a couple different things. Hardware is becoming very, very, very inexpensive. Connectivity is much more pervasive and much more reliable. Development has become remarkably easier for IoT devices. It still has a ways to go, but it's becoming easier and easier. And then companies are realizing that there's huge benefits to be had from very small improvements. There's a really neat study that GE did on how much each industry would save with simply a 1% improvement, and each of the numbers are in the range of billions. It's definitely something we see as we're working with our customers on Azure IoT. Even some of the very straightforward deployments can save a whole lot of money. And then, frankly, it's a very interesting area of innovation right now. There's a lot of new innovative scenarios that folks are coming up with. I've got a few towards the end of my talk that I'm going to be explaining, but a lot of these are very, very unpredictable and are being facilitated not just by the things that are on here, but also by the fact that IoT data is now readily combinable. There was a really interesting Vision Mobile report that came out, it was about a year ago now, that was talking about a weather forecaster who was trying to improve weather forecasting, particularly their rain models. And one of the hardest things about predicting rain models is knowing whether you were right or how right you were. And so typically a city will have 10 weather stations, and that's not a very good amount of sampling. What you really want is millions and millions of little sampling points. And so this weather forecaster teamed up with a car manufacturer that was collecting telemetry that also included windshield wiper speeds along with time and location. And that really speaks to and we're able to refine their rain models. It really speaks to the unpredictability of IoT and the unpredictability of what's going to happen as we start to combine signals from various devices. Looks like I'm going manual today on the clicker. Okay, so IoT is changing quite rapidly as well. This is sort of what IoT looked like in 2010. There were definitely some IoT innovations that were happening. And when you fast forward to 2015, things look remarkably different. There's a tremendous amount of activity on IoT across consumer, across enterprise, across B2C. And we think that by 2020, it's not going to fit on this slide with the rate of increasing innovation that we're seeing. And there's a set of disruptive forces that are causing this to happen. In addition to this being widely seen as the next wave of computing, and many of the mobile developers today that are transitioning to IoT, a lot of them are sort of rebranding themselves as IoT startups. But there's a couple really interesting disruptive forces. Of course, Moore's law continues to increase. Metcalfe's law about the value of the network being the square of the participants is really interesting with IoT. And it's not just that we think it's as simple as every IoT device is going to connect to every other IoT device. It's really not that simple. But we do think that IoT data is going to be combined in lots of interesting ways that is very unpredictable, like the one that I just gave about the weather forecasting. And then also Kumi's law states that for a certain computational capacity, the power necessary for it is rapidly decreasing. And so that allows field-deployed devices that can be put into line-of-business assets with a self-sustaining battery that'll last 3 years, and yet it can still do occasionally connected 2G radio and things like that. I'm going to talk briefly about the patterns that we see companies going through. And so we have a maturity model that we've put together based on a bunch of not only customer research, but customers that we've talked to about the different stages that they see themselves going through with IoT. And I'd say this maturity model holds up pretty well for customers that have traditionally been thing companies and are moving more towards thing plus services companies. Some startups are going right to the third phase of the maturity model and just going for it. But typically in the first stage, what we see is that customers are really after operational efficiency. They're primarily connecting devices and monitoring telemetry from those devices. Fleet management is a really good example of this, where just knowing where your fleet is and being able to set rules and alerts and geofences and things like that has a tremendous amount of value. This phase of the maturity model is really dominated by being able to not only monitor device state, but also being able to set rules and alerts. And this is a stage where you reap a set of efficiency improvements that typically are actually that have quite a payoff for companies. And this is really just the start. This is where we see companies start. And typically what we see as well is that companies will start with a proof of concept and go to a limited pilot and then go to a more sort of aggressive rollout, sort of take it slow. But then the second time they go through that, it goes much faster because the value is very evident and a lot of the unknowns are now known. The second stage that we see companies going through is one we call business intelligence. And this starts to be dominated by analytics. For example, on the fleet management example that I just gave, you can start to use analytics, not just about data. You can obviously do route optimizations by combining traffic data and things like that. But then you can also start combining other interesting data, like did one of the fleet get robbed at some point? Are there typically higher traffic flow areas? What are the times of the day when that occurs? What are the times of the year when that occurs? And you can start to actually dramatically improve your efficiency using analytics. And so this stage is really dominated by taking that data, combining it with other data, and using rich analytics that are oftentimes batch. In other words, you're doing it periodically to improve things. But then towards the end of this part of the maturity model, we see companies operationalizing something and doing it in real time, tracking something in real time, notifying, rerouting, and things like that. And then the final stage that we really see, we call business transformation. Business transformation is really where you've evolved from just a sort of a thing company to really an IoT company, where the primary revenue is being generated by these new IoT services. So a great example of this that we've talked about publicly to date is ThyssenKrupp Elevators, who is using the Azure IoT services today to improve the way that they service elevators. So a little bit about ThyssenKrupp. So they have 1.1 million elevators worldwide. There's about 100 different models. And each one of those elevators has a set servicing schedule. So they get serviced, Model 1 will get serviced on 4-month increments. Model 2 will get serviced on 6-month increments. And it turns out set servicing schedules, and this is true across all of industry and enterprise, set servicing schedules are pretty lousy ways to predict when you need to service. You're either typically going to undershoot or way overshoot when you do your servicing. For elevators, it turns out a much better way to predict when you need servicing is to take into account things like how many trips did it make, how much weight was in each trip, what's the operational temperature of each of the components, and things like that. And you can imagine a rich set of signals, some of which they had and some of which they're adding, which combined with rich machine learning can actually tell you when it's time to service an elevator and can tell you in real time when it's time to service an elevator. ThyssenKrupp thinks that they can dramatically reduce the amount of servicing that they're doing for their elevators while making it so good that they can offer uptime guarantees as a service. And so this is something that you'll see a lot, especially in the enterprise side, is that predictive maintenance, predictive stocking, predictive really anything for your things is very much a key part and a very, very key revenue driver for IoT. And so most people, when you talk to them about IoT, if you ask 100 people, you'll get 100 different answers. And that's primarily because IoT is as broad as the computing industry. And so it really just depends on where you're coming from. Some people it's Microsoft Band, some people it's Nest, some people it's Arduino. It really just depends. But certainly on the enterprise and B2B side, we see predictive maintenance and predictive fulfillments and stocking as being one of the key revenue drivers for IoT. So IoT has its own fun challenges as well, in addition to some of the things I'll be talking about later. There's an area already, a lot of you are probably familiar with, around operational technology, which has its own sets of, its own patterns of excellence for securing things, for maintaining things, for providing access to things. And then there's this other thing that you're probably very familiar with around information technology. And right now, to a large degree, these are two giant divides. And IoT is a really interesting inflection point because, for example, when you consider ThyssenKrupp with their elevators, and they have an IT department, and they obviously have an OT department as well. And for IoT to work successfully, OT and IT have to work really well together. So IT and IoT collaboration is one of the primary things that will, as far as from the cloud on down, that will enable IoT and is very important. And nowhere do you see that more than in the area of cyber-physical security. IT engineers, of course, know how to make digital things secure. There's a secure development lifecycle, secure networking technologies, threat modeling and vulnerabilities. There's a set of industry standards around this. OT engineers knows how to make things physical things safe and secure through standards, procedures, continuous improvement, restricting physical access, doing hardware and risk analysis and things like that. There's a great talk later this week by Clemens Vaster on IoT security fundamentals that covers this in much more depth. But this is a great example where if you want to actually have cyber-physical security for your IoT deployments, especially in the enterprise, this really requires IT and OT engineers to collaborate. So IoT is a large opportunity, no way about it. The estimates vary. Gartner predicts that by 2020, there'll be somewhere around 25 billion IoT devices that are connected. IDC estimates that IoT is going to have a $7.2 trillion impact on the global economy. We're not making any claims here. We do know that it's big, certainly based on the customers that we're talking to and the initial projects that they've already undertaken and the initial benefits that they've seen. We think it's a very, very large opportunity. So let's get to what Microsoft is doing about IoT. So I'm going to talk about two things today. First, I'm going to talk about Azure, then I'm going to talk about Windows IoT. So Windows IoT is obviously, Windows has been around for a long time, certainly in the embedded space. I'm going to be talking about what Windows is doing for IoT, starting with Windows 10, which is pretty exciting and significant. I'm also going to talk about Azure, and of course, with cloud-based solutions, you would expect that they're very, very easy to provision, easy to use, easy to manage, that they're pay-as-you-go and scale as you need, and that they also have a global reach. A lot of these IoT solutions, take fleet management again. A lot of these IoT solutions have a global footprint, and what we're hearing from customers is that they really, in addition to wanting a cloud solution for IoT, because they're centrally managing their solutions, they need a cloud that's global and hyperscale because they have deployments in various regions. And what they don't want to have is different implementations in each region. One of the things I want to stress is that Azure, in addition to end-to-end security and privacy, and we'll be talking about that as well, we have a fundamental pitch that it's the Internet of Your Things. That's our sort of marketing campaign for IoT, that it's the Internet of Your Things. And what that means specifically is that we help companies and we help startups and we help ISVs extract value from their IoT devices, regardless of whether those devices are running Windows or Linux or real-time operating systems or iOS or Android. We're very, very friendly across that entire spectrum. And you'll see in a few slides some of the commitments that we've got to making that not just a bullet point, but an actual product truth. So, on to Azure IoT. So I'm going to cover, in addition to cloud-based IoT solutions, I'm going to frame the IoT landscape by talking about a series of IoT device and cloud patterns that we see again and again in these solutions, and how customers are using our Azure IoT services. I'll talk about the Azure IoT services, and then I'll talk a little bit about the Azure IoT Suite that we're going to be previewing later this year. So when you boil down a cloud-based IoT solution, it's easy to get sort of lost in the weeds in IoT. IoT is, again, very, very large, and even cloud-based solutions are quite rich. So when you boil down an IoT solution and cloud-based IoT solution, you really look across three different areas. The first is around device connectivity and management. This is almost always present in IoT solutions, unless customers are simply doing batch upload of data. There's analytics and operationalized insights. That's a very important part of these IoT solutions. And then finally, there's presentation and business connectivity. I'm going to walk through each one of these areas. Okay, so we'll start simple, as all good patterns do. So over on the left-hand side, you see a set of devices. These devices are running real-time operating systems like ARMBed or FreeRTOS. They're running Linux, they're running Windows, they're running Android and iOS. So we have a rich set of devices, and then we have a cloud. And I'm going to fill up the cloud with a set of patterns. The first pattern that I'm going to talk about, again, is the device connectivity and management. So some devices are able to connect directly to a cloud gateway over the open internet. And a device sometimes is appropriate to do that. Not always. It's definitely something worth checking out our IoT security talk later, because some of these devices, especially when they get very, very, very small, if they're acting as servers that can accept inbound requests, are not going to have such a great experience on the open internet. There's a fun search engine. I actually forget the name, but we saw it about a month ago. There's a fun search engine that lets you find IoT devices that are on the open internet that don't belong there, like gas stations. And then along with your search results of IoT devices, including their IP address, is a list of exploits, like telling the gas station that it's empty, which is loads of fun. So these are not the kind of things you want to take lightly with IoT. That said, there are some devices that you would actually connect over the open internet to a cloud gateway. And of course, in a secure fashion, using TLS and all the best practices and things like that. So today we have our Event Hub service. This is a generally available Azure service. It's available worldwide, including in China and our government cloud. It supports HTTP as well as AMQP for protocols. It's primarily a high-scale telemetry ingestion service. That's really what it does. Each event hub that is very quick and easy to provision, you can go and provision them in minutes. Each event hub supports 1 million unique publishers, so they can each have their own unique token to identify them. You can revoke them and things like that. And it supports, all told, over a gigabyte per second of ingress per event hub, and you can actually have multiple event hubs in your solutions. This has been quite a successful service. We're seeing very much a hockey stick right now of adoption for this thing. About a month ago, I was saying we were doing 10 billion messages per day. We're up to 18 billion messages per day, and that's per day. That's across all of our customers' event hubs. And that's IoT devices. We see that from website telemetry. You can use it for that. You can use it for a variety of purposes, but it's very, very useful in IoT. And the examples that I'm going to be giving later today about some of the customers that are already using Azure IoT services for their deployments are using event hubs. We're also ingesting somewhere north of 60 terabytes per day through these IoT hubs. And a lot of it is just little teeny messages with JSON payloads or binary payloads and things like that. Okay, a far more common pattern that you see in IoT is that of a field gateway. And I say pattern because it really is a pattern. For example, I consider a mobile device to be a field gateway. There's some, or an optional field gateway. There's some customers today that have IoT devices on vehicles where there's sensors in the vehicle and they connect to through Bluetooth LE to a smartphone, and then they do data aggregation and real-time control from the cloud. It's an example of a field gateway pattern. There's also, of course, field gateways from all of the popular hardware manufacturers that do all sorts of fun things. One of the things that you'll hear in our security talk that these field gateways do is they can provide a network isolation and a security boundary for devices that are ill-equipped to be on the open internet. And they basically act as a proxy for those devices and still can communicate to our event hubs. And another pattern that you see on these field gateways is that of protocol adaptation. So, IoT has been around for a long time, like I said earlier. There's a lot of protocols that folks have either invented or started before the internets came around. And a lot of these protocols aren't so awesome to communicate with over the open internet. And so a very common pattern that we see is that of protocol adaptation at the field gateway level for this reason. Okay, so that's event hubs as our sort of first cloud gateway. There's actually additional IoT needs, as most of you in the room probably understand. IoT is not just about ingesting telemetry and doing something with it. That is certainly a significant part, and a lot of what we see right now is using that. But there's additional things that you need. You need the ability to issue commands to devices and know whether a device received that. You need the ability to have basically an inbox-outbox per device. You need the ability to have an identity for each device in your system, of course. And you need a device registry that can store extensible metadata about devices like manufacturer, version, firmware, things like that, so that you can build rich portals and queries and things like that on top of. And then, of course, you need device management. You need the ability, this is something that becomes very apparent when you have a large IoT deployment. When you've got those 1.1 million elevators, it turns out if you have people that are going around and flashing them to update those devices, it takes a long time to do that. So what you really want is to be able to centrally manage these things and roll out operating system updates with rollback, update configuration files, update software that's running on it that's collecting telemetry. So I'm excited to announce that with the Azure IoT Suite that'll be coming in preview, we've got a service that's included with it called the IoT Hub. So this is a capability of the Azure IoT Suite. It provides for bidirectional device-to-cloud communication. It actually supports up to 10 million devices per IoT hub. And then, of course, you can have multiple IoT hubs in your solution if you need more. We're not seeing a lot of customers with more than 10 million devices right now. But if you look at that 25 billion devices connected by 2020, you can imagine needing that. So in addition to doing telemetry ingestion, which of course it does, It also has a command and control facility. It will actually maintain 10 million unique connections to those devices to use both as a telemetry channel as well as a command channel. It has a device registry and identity registry, so you can register your devices with this service. You can add extensible metadata about each device to it. We will be providing, as part of the Azure IoT suite that I'll be talking about later, we'll be providing a set of rich finished apps on top of this that include portals and things like that so that you can see all of your devices and tag them and filter them and things like that. So this is a mechanism on which that's built. It supports HTTP as well as AMQP. AMQP, for those that don't know, is the Advanced Message Queuing Protocol. It's a standard. We also will support MQTT through an extensibility mechanism on the IoT hub. So just talking about this a little bit as well, one of the things you'll see us do is we will tend to be fairly conservative at the protocols we support at the cloud gateway level, but more promiscuous of the protocols that we support down at the field gateway and device level. And I'll talk about our device support in just a second. At the cloud gateway level, we do think that extensible protocol adaptation is important, and so we will be supporting that on the IoT hub. I'll give you a great example. We're working with a customer right now who said, hey, I've got this protocol that I already use across the open internet. We feel good about it. It's secure. We invented it. And what we don't want to go and reinvent a cloud gateway. We want to simply be able to reuse the cloud gateway but still continue to use our protocol. So can we please have the ability to do protocol adaptation at the cloud level? Because we don't want to do protocol transformation all over the place on field gateways. And so that's one of the reasons why we added this. Another reason is that the MQTT as a messaging format, it's a great, nice, lightweight, sort of tailored for IoT. It's still a little bit immature. There's some parts of the MQTT spec that if we actually honored, we would be doing things like allowing clients to send us 50 megabyte files and to retain them indefinitely without a lease on them. And so we're going to be working with the industry on evolving MQTT. And as MQTT evolves into a broadly adapted standard, we'll add first-class support on our cloud gateway. Until then, we have this protocol, extensible protocol support. So I mentioned a little bit about the Azure's position that we fully embrace the Internet of Your Things and all of the devices, and we're backing it up with product. And so as part of the Azure IoT suite, as we preview that this year, we'll also be providing a set of cross-platform SDKs. And so these SDKs, we call it our agent framework. These are libraries that can run on a variety of operating systems. They run on real-time operating systems like ARM. So right now we're partnering with ARM to integrate our agents with ARM Embed 3.0, or I should say to make them available for ARM Embed 3.0. These agents then are able to securely communicate bidirectionally with the Azure IoT Hub for the Azure IoT Suite. And ARM Embed is really interesting because ARM Embed runs down on Cortex-M devices that work on microcontroller-based devices that are shipping today in the billions. And so this is a sort of significant amount of reach that you'll get from ARM Embed. There's other real-time operating systems as well that we'll support, like FreeRTOS. There's a bunch of these. There's a whole lot of Linux variants that we'll support. I'll draw your attention to a notable one that we're partnering with right now. So we're partnering with Canonical on Ubuntu Snappy, which is a really slick little IoT. It's a cloud-based Linux variant as well, but it's also an IoT-based operating system that can run in a very small memory profile. It uses a novel approach to software updates, which is that of simply Linux containers, to be able to push Linux containers down to update the operating system or to be able to update apps that run on it. So we actually already have our agents running in that today. Windows, we of course have rich support for with Windows 10 IoT. Our agents work great there, and we'll be able to light up additional security capabilities. And of course, Android and iOS. So all of these will be open sourced. Just to reiterate, these are not required. You don't have to use these agents and run them on your devices. We support industry standard protocols that you can interact with our cloud-based IoT solutions. They're simply there to make things easier, and they'll be open source so you can freely modify them. The way they work is that there's a set, we have a bunch of cross-platform C code that we compile through every compiler on the planet. to make sure that it's actually compiler neutral. There's an OS abstraction layer for our cross-platform C code that abstracts anything that's different across operating systems. This is sort of normal cross-platform stuff. Abstracts things like threading and memory management and networking and things like that. And then it has a set of OS bindings. The nice thing about this is that if you wanted to port from Linux variant 46 to 47, it's simply about providing a new OS binding. It's not about having to build new code. And then as part of this, we'll also be providing a C API, a .NET API, a Java API, as well as a Node binding for JavaScript developers. So a rich set of APIs for every developer. The C API, we're providing a C API simply for embedded development, so that if you're running on something like ARM embed and you're, where you don't have a lot of memory, and you want to be very, very memory sensitive, our agents run in kilobytes of memory on that as opposed to megabytes of memory. And of course, we have rich .NET APIs, Java APIs, and a Node binding. Okay, so that's really around, that's the first part of our tour around device connectivity and management. Most people don't wake up and say, I just want to connect devices for fun. There's some sort of business associated with it. There's something on the other side of that connection. And it could be as simple as, I'm doing fleet management with alerts and things like that. Or it could be much more interesting. So I'm going to start talking about some of those interesting things. But before I do, let me just say, there's sort of a pattern that you see again and that we see again and again that customers go through with this part of the IoT solution. The first stage is around finding insights into your things, or finding insights from the data from your things, to either power new services like ThyssenKrupp offering uptime guarantees as a service, or to improve things. And actually, most manufacturers that we're working with on IoT are actually using the telemetry that's coming from these, coming from devices to then improve subsequent generations of devices. So the patterns that you typically see here with batch is around batch analytics and visualizations. And so primarily the star of this show is machine learning. And so we have Azure ML, which is generally available. It's a rich set of offerings that allow you to have a nice drag and drop experience and to build ML models. There's a whole bunch of off-the-shelf ones, and there's a whole bunch of open source support that we have here as well for rich ML models. Makes it really easy to find interesting insights into your data. There's Azure HD Insight for MapReduce, and there's Power BI, which is a new service in preview that allows you to visualize data. Finally, there's new services like Azure Data Factory, and there's another one on here that I still haven't had a chance to update my slides on, which is Azure Data Lake for massive amounts of data that are being sent to the cloud. So the pattern that you typically see here is that you take a sample of your data, you run it through ML, you run it through a few algorithms, you tune your algorithms, and find those insights that's required to power those new services. Once you have those insights, it's not enough typically to do something on a batch and periodic basis. What you really want to do is operationalize those insights. So going back to the ThyssenKrupp example, when an elevator, let's say for example that an elevator happened to have a dramatic increase of activity in it, and the ML models are telling you that it needs servicing not a month from now, but a week from now. And so what you want to be doing is monitoring that in real time so that you can order parts and roll a truck and set up time with the hotel or wherever the elevator is. So you want to do something in real time. For that, we have Azure Stream Analytics, which is a high-scale telemetry ingestion, complex event processing service. And so you can simply connect an event hub, or you'll be able to connect an IoT hub to an instance of an Azure Stream Analytics. In fact, it's as simple as going into the portal and saying to your Azure Stream Analytics instance that my event source is that IoT hub or that event hub, and data will just automatically flow through it. Azure Stream Analytics has a very simple SQL-like interface. It's very, very easy to use. You can simply query a high-scale telemetry stream as if it were a static table. And you can do things like do joins with real static tables. And it includes tumbling windows, so you can do things like, over the last 5 minutes, based on the telemetry that I'm seeing from this device, what is the probability that this device needs servicing ahead of its scheduled window? So you can do those kind of things. Azure Stream Analytics is already generally available, and as part of its service evolution, it will allow you to do real-time ML scoring over that high-scale telemetry stream. So imagine that. Imagine 10 million devices all sending telemetry at some high frequency, and having a service that can actually monitor each individual one and look for patterns in each individual one, and to be able to be doing real-time ML scoring as well. We also support Azure HD Insight Storm, and I like to highlight this because most folks think that Azure is very much a Windows shop, and it's really not. Azure is very friendly and open to open source and to Linux. Linux is one of our fastest growing workloads. We've got a rich set of announcements that we've made over the last year, from a partner with Docker to a partnership with Google on Kubernetes to a recently announced partnership with Mesosphere. So, part of what we're doing as well is we're starting to fold in additional open source projects and offer them as open source services. And so Azure HD Insight Storm is simply Apache Storm, as is, running in Linux as a hosted offering. And so if you want to use Linux for Apache Storm for complex event processing in your IoT solutions, and you want to, you're a Java developer and you want to use that, great, we love it. We want your workloads. So this is really the pattern around hot path analytics. And again, this is really about monitoring in real time that extreme telemetry scale and finding those insights from it. And the last one needs a little bit of explanation. And so this pattern, the hot path analytics pattern, works great when you're dealing with homogeneous sets of things that are each sending data independently, like those elevators or like fleets and things like that, fleets of trucks or whatever. When things in the real world start to form graphs and hierarchies and to start having logical parent-child relationships, and you want to run business logic over that, that pattern really breaks down. Complex event processing doesn't really work. And so what you really, really want here is you really want to have a distributed object model. You want to be able to describe your IoT things in the logical relationships that they exist in. So I'll give an example of building maintenance, where if you're doing building maintenance on something like a company for this, like the scale of Microsoft, where you have the world, and the world has a set of campuses, and each campus has a set of buildings, and each building has a set of floors, and each floor has a set of rooms, and each rooms have sensors in them. And the sensors are doing things like monitoring temperature, monitoring movement, monitoring light, monitoring all sorts of things, which they do. And today, our facilities management is fairly unsophisticated. I get in very early and usually have to wait a couple hours before the lights come on at 7 a.m. And what you really want to do is you really want to say, it's a true story, bring my flashlight. So what you really want to do is you really want to have business logic that you can, again, program in the cloud and be able to update and deploy, that does things like, when a critical number of motion sensors have gone off on each floor, then activate all the lights. So the interesting thing about that is that what you really want is that object model that I just described, where you've got the world and then campuses and buildings and floors and things like that. And so we recently announced a new service offering. It's our next generation platform as a service. It's called Service Fabric. And Service Fabric is the service substrate that we actually build our own services on. And we're offering to developers the actual real service that we use ourselves. And so Service Fabric is a service that things like Event Hubs is built on, that IoT Hub is being built on, that SQL Azure is built on. We have 1.4, I believe, million databases that are running on this today. Bing Cortana runs on this. There's a whole bunch of services. And so this is an extreme scale service that can go from just a few nodes up to tens of thousands of nodes. And we have an API in it, an actor framework, that allows you to model your objects in the real world in a distributed object model. And what you can do then is simply, we have an adapter that can simply take that telemetry stream, look up the object that it represents, that each signal represents, update it, and then your business logic can be running in an event-based fashion within that cluster. So, And with our command and control facilities through the IoT hub that are going back, if you decide that when a critical number of sensors, you can imagine having an event handler where you're simply listening for motion sensors and you're keeping track of how many have been activated over a certain time period. And when a certain time period had been, when a critical mass had been activated, then you could simply walk up to the floor object and to its lights collection and say, turn on. And that command gets issued back through the IoT hub and all the way back down to devices. Very, very simple. And then when you decide it's time to update you have a better algorithm and it's time to update it, then there's one place to do it. You push it to the cloud and it's automatically live update. One of the things we do support with Service Fabric is rolling live upgrades and rollbacks. And so you can take an extreme scale service like Bing Cortana, which is processing billions of signals from people, and you can actually roll out live updates to an existing cluster. You don't have to stand up another cluster and do a switch between the two. So we think this is a really important pattern in IoT. I'd say about a third of the customers that we talk to see this pattern and say, oh yeah, that's great, that's something that I need. And the other 2/3 are more on the, I have homogeneous sets of things and I'm sending signals from them. And so it's something that when you need it, you really need it. The last part of our tour is really around business connectivity and presentation, because of course you need optics into your IoT solutions. Of course you need to be able to manage them from websites and mobile services. We have app service for that. Of course you need to be able to integrate them with your business. We have Dynamics, BizTalk Server, notification hubs, and of course a rich set of third-party customizable, pluggable connectors to different workflows. So for example, when that truck in your fleet management is broken down on the side, there's a set of workflows that happen from sending another truck to alerting something to, these are the kind of examples of connecting IoT into your business that you need to do. And so we feel with this, and I'd say there's one last part that you need of all of this. You need solutions that are easy to provision and manage and deploy, and that have a very simplified billing model for all of this. And so I'm going to be talking about that in just a minute. But we think this gives a really good end-to-end view of the field of IoT and where we see customers going today and tomorrow, and what we have available today and what we have coming soon for IoT. Okay, so these are the sets of Azure IoT services today, from Event Hubs to Service Bus. Of course, lots of different storage options. There's new ones like Azure Data Lake that are coming very soon. Machine learning, stream analytics, app service. There's a rich set of these. So let's talk through some customer examples. I've given some customer examples. I'm going to give a few more now. So Rockwell Automation is a company that we're working closely with. Rockwell does a variety of things. They've been around for a long, long, long time. They do a lot of great things in industrial automation. One of the things that they're doing with us right now is around predictive maintenance of oil and gas pipeline supplies, so that our pipeline parts, so that as those parts are being used, they're constantly monitoring them in real time by having telemetry sent through Event Hubs into Azure Stream Analytics and doing scoring with real-time scoring with Azure Machine Learning in order to predict whether those pumps are going to fail or not, or whether those parts are going to fail or not. There's a lot of benefits that they're seeing from this. The Stanford Linear Accelerator is actually connected to Azure now and is sending real-time telemetry from many of the parts that are in the accelerator, especially the expensive ones, that you really want to monitor in real time for signals that they're going to break down, so that they can schedule experiments around those servicing windows and things like that. The Monterey Regional Water Pollution Control Agency has partnered with a company that we're working with as well, Candy Controls. And what Monterey Regional Water did is that they found that they were using excessive amounts of energy to work on their water facility. And so what they did is they were in partnership with Candy Controls. They deployed a bunch of sensors for energy, and using Candy's technology, we're able to aggregate all the data from all of those sensors and find patterns as to why they were using too much energy, and actually optimize, because it turns out, of course, energy doesn't cost the same all day long. It costs different things at different times of the day. And so what they were able to do is offload some of their activities until times when power was much cheaper. So they were able to pretty significantly reduce the amount of energy that they were using. And now they're actually taking that and streaming that in through Azure Stream Analytics and into Power BI for real-time monitoring and also for visualization. And then the last one, I'm sorry for those that have heard this, but I love this. I swear 2015 is the last year I'll talk about this. No IoT presentation this year will be complete without talking about Connected Cow. So this is a real thing. So for those of you that don't know what this is, so Fujitsu is a great partner of ours. Fujitsu's got a set of rich IoT deployments already, powered by Microsoft Azure. They have an eco-management dashboard for manufacturing. They're doing some great work with hydroponics and growing food in old processor clean rooms, using machine learning to decide optimal growing conditions and when exactly is the right time to turn on the lights or what's the right humidity to set. But they also came up with Connected Cow, and I love Connected Cow because Connected Cow is one of those things like the Vision Mobile report of the weather forecaster and the windshield wiper data that really illustrates how unpredictable IoT is going to be and certainly the innovations in it. So Connected Cow requires a little bit of explanation. So cows are only ready to mate in very small windows. Female cows go into estrus for very short amounts of time. And it turns out if you miss that window, then you have to wait a long time. And so what Fujitsu did is they had a pilot initially where they put industrial-grade pedometers, Fitbits, on cows. And what they did is they tracked over time, was there a set of signals that we could use to tell whether a cow was going into estrus? And it turns out there was, and it's the amount of steps that they take and the frequency that they take them. And so using Azure Machine Learning, they were able to tune and alert farmers as to when those windows were, what cows were, at a 95%, it was between a 95 and 98% success rate. And the false positives, it turns out that the cows typically got loose, and so you wanted to know that too. They were able to increase calf production up 31% using this, which is quite dramatic. It was deployed on 10 farms in Japan and had quite a big economic impact for those farms. So I like Connected Cows simply because it does illuminate this unpredictability. And if you think about it, this is really just that second stage where you're not only taking signals, but then you're using analytics to find something interesting from it. So as I mentioned, in IoT, we've got a rich set of services, and what we're working on this year, and we've already got those, and customers are already building on them, and they're already generally available. And what we're working on taking IoT to the next level is to provide something that we announced recently called the Azure IoT Suite. So some details what the Azure IoT Suite is. So what it does is it will provide a rich set of finished apps for a set of use cases, from remote monitoring to asset management, which includes command and control, to predictive maintenance. And these are, so you can think of them as general purpose or very general use cases that can be customized to a variety of business needs. And so the Azure IoT Suite will accelerate your time to value by allowing you to go into the Azure portal and simply provision these. Now, under the covers, it'll go and create the IoT hub. It'll go and connect it to a stream analytics instance. It'll provision storage. It'll do all of that. But it also includes a rich set of web collateral as well, including device admin portal, solution portal, those kind of things, to make it very, very easy to get started. And then you simply plug in your devices and customize it for your data. It will be shared source, so you'll be able to customize these things. We'll also be providing simplified and predictable billing that's pay as you go. And so instead of staring at a longer list of individual services for bills, you'll have the ability to get a simplified billing model. You'll still be able to customize these. So it's not a closed service. So some of you might remember we had originally the Azure Intelligent System Service, and we recently announced that we'd evolved it into the Azure IoT Suite. Azure, the Intelligent System Service was sort of a closed system, and when you decided that it was time to grow it up and you wanted to do something else, like, to use a metaphor, climb under the body and start welding, if you wanted to do that, you weren't able to. And so the Azure IoT Suite, we do provision these easy-to-use finished apps that can scale all the way from a small proof of concept all the way up to millions of devices and global footprint. But you can still customize them. For example, if you decide I don't want to use Stream Analytics for complex event processing, I want to use Apache Storm. Great, very easy to do. Okay, I'm going to shift gears a little, and we're going to talk about Windows 10 IoT. So, as I mentioned, Windows has been around and embedded for a long time. I'm sure a lot of you know that. And it turns out Windows is a great platform for IoT. There's a bunch of interesting things that we're doing with Windows for IoT. The first is that we're making Windows 10 actually unifies the operating systems all the way down from the smallest devices, like little IoT devices. Like we recently announced that Windows 10 runs on Raspberry Pis and Miniboard Macs, all the way up to giant PPI devices and even on HoloLens. If you haven't seen HoloLens, I hope they're here, but they're really amazing. But across all of these, it's using a converged operating system core with a single Windows, universal Windows app platform that runs across them and Visual Studio support from across for the whole thing. It also includes universal Windows drivers, and so the drivers are the same whether it's a PC or a larger device or a very small IoT device. It's a unified model as opposed to being having disparate driver models. And then, of course, natural user interfaces, Cortana integration, speech, things like that. Secure. Windows is secure. Windows has a long history of providing leading-edge enterprise-grade security. In many IoT devices, this is going to be very, very, very important. Having the ability to have a trusted platform module both on the device and then have support for it in the operating system, which tells you whether the device has been tampered with, and then be able to relay that information to the cloud, is a very, very important capability in IoT. Having advanced lockdown capabilities, like actually being able to BitLocker the SD card on the device. There's a lot of fun exploits that you can do. Pop the plastic off a device and pull the SD card out and root it. Loads of fun. Not so great if your business relies on it. And so being able to BitLocker devices and lock them down. And then also for some of the larger profiles, like kiosks and desktops and things like that, being able to support multi-user profiles is part of Windows 10 IoT. And then, of course, rich connectivity, a ton of industry peripheral support, of course. A rich set of interoperability options. Windows will support AllJoin, which is, we're part of the All Scene Alliance. We'll support AllJoin. And then, of course, the rich deployment, servicing, and managing that you've come to expect from Windows will continue to work with your IoT devices, from Windows updates to M2M to Intune and things like that. And of course, it's Azure IoT ready. Our agents work great out of the box with Windows 10, and you can use these to accelerate your time to value. This is just a chart. This isn't a map of the trains in Chicago. This is the journey that Windows has taken towards platform convergence. It has a happy ending. The happy ending is Windows 10. And so with Windows 10, all of these profiles are converged into a single operating system. There's even porting tool support for Windows Embedded Compact to Windows 10. And so these are the different versions that we'll be making available for Windows 10. I'll start with the largest first. The largest is, you can more or less think of it as the desktop as an IoT profile. It has everything the desktop does. It also has a rich set of management and lockdown capabilities that you need for embedded scenarios. It runs in 1 gigabyte of RAM, 16 gigabytes of storage, supports x64 and x86. The next one down is really the mobile profile that's really geared towards phone. It includes a Windows Phone shell. It runs in a very conservative 512 megabytes of RAM, as well as 4 gigabytes of storage, and supports the ARM architecture. So that'll be another IoT profile. And then the last one is the newest and the most interesting for this audience, certainly, which is Windows 10 IoT Core. So this actually supports the same universal app model that the larger SKUs do. So you can write once and deploy to all of these endpoints. It has no shell, so there's no start menu. There's no shell. There's simply you have the ability to run apps. It runs down in a lean 256 megs with 2 gigs of storage, and it supports x86, x64, or ARM. And so all of these. And the nice part about it is Windows 10 IoT Core is free. So all of these profiles support Windows updates. They support these new user interfaces that we've been talking about. Visual Studio supports them. They have the rich set of security and identity services. They'll support all join. And then they come pre-configured for Azure IoT as well. And then we recently announced, for those that aren't aware, but we recently announced that Windows 10 IoT Core is available as a preview. You can go to windowsondevices.com. It runs on a Raspberry Pi 2, which you can get for about $35. They're actually a lot of fun to play with. So the profile runs on that. It also runs on a MinnoBoard Max. And like I mentioned, it's absolutely free. The nice thing, actually, let me go back to this. This site not only contains the Windows 10 IoT Core profile that you can download and put onto these boards, but it also contains a rich set of recipes for building things. Like there's a robot project and there's a weather shield project and all sorts of fun stuff. If you're ever tempted to do something like that, it's a really fun way to get started. And you've got full Visual Studio support for building all of those projects. And then just to wrap up, of course, as part of Windows 10 and why we think it's interesting in IoT is it does support this complete life cycle of the device, from enrollment to inventory to application management. It supports rich MDM through OMADM. So it supports not only Intune, but also other management solutions. And so for enterprise, this is interesting because you can manage your IoT devices like you manage your other Windows endpoints. And we have, so there's a few more talks that we have here, actually quite a few. If you search for the IoT keyword, you'll find all of these. A couple to draw your attention to. Kevin Miller from my team will be presenting a deeper look at the reference architecture for IoT, how all of those solutions are actually being built. Clemens Vasters is presenting IoT security fundamentals. Dan Rosanova will be talking about Azure Event Hubs. We'll have an overview of advanced analytics with machine learning plus data orchestration from Si Young. We have a deeper dive on connecting devices to the Azure IoT suite. And then some great talks on Windows 10 and the Internet of Things from Colin, as well as Drew Pearson. So with that, I am going to take questions. And if you do have a question, I'll ask that you come up to the microphone. And if you don't have questions, have a great rest of your day. Yeah, question over here.
Can you hear me? Yeah.
I can.
So the 10 million limit for the IoT hub,
Yes.
that's a great number, right? I don't know if someone will exceed that, but just curious, since cloud is supposed to be limitless, theoretically, what is the limit? Is it a database limit? Just curious.
It's a design limit, really. It's I'm sure we will be increasing that number. It's a great design point that we feel like we can achieve. Cloud is limitless, and so yeah, it's really just a design goal right now.
Okay.
Yeah.
Thanks.
Sure.
Going to come out? Oh, sorry, someone's talking.
Go ahead.
Is Windows IoT going to come out at the same time as Windows 10? Windows 10
Yes.
IoT?
Yes.
It will? Okay.
Yes, and it's available for preview today.
Cool.
Yep. Wow, I've answered everyone's questions. That's amazing. No, there's another one. Okay.
What restrictions, if any, would exist with applications developed for Windows IoT versus mobile or other Windows 10 platforms?
Do you mean like platform limitations?
Limitations on what you can do with the application.
As far as platform capabilities or commercial restrictions? Or
UI.
UI, got it. So we have a great demo in the Windows talks that shows UI that's being written as a universal app that is running on a Raspberry Pi over an HDMI output. So it has basic support. I'm sure there's some limitations I'm not aware of. I'm pretty sure there's not a web browser, but don't quote me on that, because there are a lot of apps that have been taken out to get it down to that profile. Probably the best way to find that out is to go to the Windows 10 talks and ask about the specific platform restrictions.
Do you know if there's any differences between what you can do in terms of are the APIs different for what's available will ultimately run on ARM versus Raspberry versus x86?
No, and in fact, if you're using the Windows runtime APIs, that's abstracted from you.
Cool. Okay.
Yeah, thanks. Yeah.
I noticed you didn't mention the .NET Micro framework. Is that kind of gone in lieu of the Windows 10 core? As far as IoT?
Yeah. It's a good question. I believe it's still available on the smaller profiles like CE. The major investment is around the Universal App Platform.
Are there commercial restrictions as to what you can do with the Windows 10 IoT core?
I'm going to have to follow. Actually, why don't you find me afterwards,
okay,
and I'll follow up with you.
Okay.
I'm not aware of them. It is free.
Yeah. Well, some of the free other OSs, for instance, don't let you use them in a nuclear power plant. And not that I want to use it in a nuclear power plant, but that would be the kind of thing I'm thinking of.
Right. Yeah. Come and find me afterwards, and I'll
Okay,
look it up for you. Yeah.
I'm interested in knowing how much it costs, for 10 million devices. How much it costs to connect them.
It is a pay-as-you-go sort of scale-as-you-need approach. We're doing some modeling right now on pricing. We haven't disclosed pricing yet for the suite. There is pricing available for most of the services, like Event Hubs. Event Hubs is phenomenally inexpensive. I forget the exact pricing, but it's very, very inexpensive. Most of the services are quite inexpensive. It really is going to depend on, we'll have a pricing for the Azure IoT suite, which simplifies it. We'll have sort of you could do per device, or you could do based on how much data you're ingesting and things like that. That'll be, we think, very competitive with existing solutions in market today from some of the vertical application enablement platforms. If you decide to customize it, and if you decide to add additional services, then you just sort of pay for those as you go. But it's very inexpensive. In general, cloud is very inexpensive.
Right. And is there a way to tunnel back to the device itself? Like, for example, I want to connect to the device by remote desktop. Can I do that?
Great question. So there's nothing that we'll do, we won't enable remote desktop through the IoT hub down to devices, but there's nothing that prevents you from remoting to those. Does that make sense? It's your fleet of IoT devices.
Okay.
You could connect to them directly. If your question was, will we do that off the IoT hub?
Right.
We're not planning on that.
Right.
That's
as part of the IoT core, Windows, for
Yeah.
example, is there a way we can tunnel back?
Oh
to
yeah,
device,
definitely. Yeah. Oh yeah. When does
through VPN, or how does it work?
you can RD to it. You could VPN. It's Windows, so anything you can do with Windows, you can do with it. Yep.
Okay. We are using Event Hub today, and for scalability and distribution, we are using Orleans. And this service fabric and actor-based computing, is that Orleans sort of?
Yeah, it uses the same API pattern that Orleans has.
It is?
Yeah.
Okay. Will that affect the price that you're using, or that you have today?
So let me be clear. So Service Fabric has an actor pattern to it, or an actor pattern API.
Yeah.
It's It's a very common pattern. It's the same pattern that you find in Orleans. Orleans is an unrelated open source project that Microsoft Research did. Yeah. We just thought the APIs were so good that we built them into Service Fabric. The reason why we built the APIs onto Service Fabric is that Service Fabric has a rich set of services, including support for stateful microservices, so that you get replicated backups. And so Service Fabric actors are actually durable and resilient to data loss. And so you can kill a VM and they survive and that kind of stuff. So there's also a blog, that's the Orleans team has put out on how to run Orleans on top of Service Fabric. You can do that too. So it's really whatever you want to do. There's no sort of per Orleans pricing or anything.
No.
And in fact, for Service Fabric, we really charge based on compute.
Yeah.
Yeah.
Thanks.
Great.
Question about the data that is collected. Is the data stored and managed and owned and retained within Azure IoT, or is the data itself passed through to another data repository for long-term retention?
Oh, so great question. So actually, are you asking about for the Azure IoT services today or for the suite tomorrow?
Well, I guess probably both.
Okay, fine.
Yeah.
So for the services today, it's really, the model that you follow is you go provision blob storage or SQL or whatever. It's yours. You own it entirely. You control it. It's your sovereign data. And then you can have event hubs and stream analytics as intermediaries to do additional processing, like ingestion from IoT devices, complex event processing. The same will be true about the suite. You'll be able, the suite will add easy provisioning and simplified billing, but it's still your data, your sovereign data. It's not passed through to any other data service or anything like that. You can get to it. You can remove it. It's your data.
Okay, it's not used as some other part of an aggregated data
Absolutely
mining
not.
system.
Absolutely not.
Okay.
It's the internet of your things. It's also the internet of your data.
Gotcha.
Yeah.
Hi.
Hi.
In all your scenarios, you have been assuming that we have those sensors ready and all the hardware ready, but there are customers out there or companies that want to use Internet of Things, but they don't have any idea how to get sensors and hardware. Mm-hmm. Do you have any partnership with anyone, any company that can provide me with sensors and hardware that can connect to an Azure Event Hub easily?
Yeah, that's a great question. We have a program that's going to launch that's helpful for that. We do have some partnerships that we're about to announce as well, but we have nothing to announce right now. But we realize there's a need for it, and we will soon.
And another question, I didn't see you have, with the current product you have, I can send, using Python, I can send data to Event Hubs, but I didn't see Python in your slides. You had C, Java, .NET, and JavaScript.
Yeah.
Will you be providing API for Python as well?
Yeah, we're certainly open to requests, and so if we hear enough folks that want Python, we'll absolutely add it. And like I said, it's an open source SDK, and if the community adds Python, we'd love it. But if not, we'll add it if we hear enough.
Okay. And the last question.
Sure.
Do you have? We already have customers using Event Hubs, Stream Analytics, sending data in, and using Power BI. And things like that. And when we move to Azure IoT Suite, will all of those components will be working? Or should I do something to move them into Azure IoT Suite? Or
No, it's a good question. So you're asking the question of what's my migration story between Azure IoT services and the Azure IoT Suite. There's a couple different answers to that. One is if your solution's already working, great. Keep using it. If you decide, for example, I want to use command and control, and I want to switch from, for example, an event hub to an IoT hub to realize that benefit, there will be an ability to do that.
It's not the same thing. IoT hub and event hub, they're not the same thing, right?
They're two different services, but IoT hub, I think of the IoT hub as an aggregate service. It uses event hubs for telemetry ingestion. So the APIs are the same.
Okay, I understand. Thanks.
Sure. All right, thanks everyone.